So next is the naturally aspirated systems and forced induction systems. So in this one is very important regarding the turbocharger and the intercooler. So in a naturally aspirated engine, the air is drawn into the cylinders at atmospheric pressure, limiting the amount of air and fuel that can be ignited. So that is whenever the piston comes down, according to the piston coming down, the air from the atmosphere will be taken as per the requirement inside. So that is the naturally aspirated. So something like we are inhaling and exhaling. If something happens here also in naturally aspirated. Imagine if we use a turbocharger here. Okay. So next comes the forced induction system and the intake air cooling system. This is very important. So let me go ahead with this. So in this one we have two types. There is one is the turbocharger, another is the supercharger. So in the forced air induction system, a turbocharger is fitted directly to the engines to compress and push more air into the engine. As I said, this is the volume. You need to give much more air to get much more better performance out of the engine, right? So we do use a turbocharger. So this increases the engine power and the torque as more air and fuel is pumped into the engine. And as well, when the turbocharger is given inside the engine, right? So this gives you much more cleaner emissions also and far more better performance. For illustration purpose, this is a turbocharger. There's a air inlet here, so this takes the air inside in a centrifugal way. It compresses the air and sends it to the engine for burning. And the fab statement for the turbocharger is that turbocharger. So there's a feature. The advantage is increased engine power. The benefit is driving pressure. Improved torque at low RPM, better acceleration, reduces fuel consumption, lower fuel bills, better burning of the fuel, lesser emissions. As I said, when you use a turbocharger, so these are the advantages. You get much more better engine power. So torque at a lower RPM, even at the low engine RPM, you get more better torque, and the fuel consumption is much more lesser because complete burning of the fuel is possible, and better burning of the fuel. So emissions are much more better. The benefits of these are the driving pressure is much more better acceleration. You get lower fuel bills so that you don't have to fill very often if the fuel efficiency is much more better, and then the emissions are much more cleaner. When we speak about the air cooling system, so there's something called intercooler. So an intercooler is a mechanical device which is used to cool hot liquids or gases. This is basically a heat exchanger. The same intercooler is used in the automobile. Intercooler is used to cool the exiting hot air out of a turbocharger and entering into the engine for the combustion, right? So this process makes the air much more cooler and denser to get the better performance and lower emissions. So how it works, let's see here. So this is the hot air coming out of the turbocharger, and this passes through the intercooler and gets out from the other side. This works like something like a normal duct only, but it has many fins in between. So that in this what happens, the air from outside, that is in the front of the car, the air passes through the fins and gets out to the engine. And when the outside air passes through the fins of the intercooler, right, the air which is coming out of the turbocharger, which is sent inside the intercooler, it gets cooled because outer air is cooling it, and when it's exiting, the temperature of the inlet and the outlet will be differing. That is, more at the inlet, lesser at the outlet. From this part, straight goes to the engine cylinders for more burning. There's one thing: when we cool this hot air, right, the oxygen levels density will be much more better, so that we are giving more better oxygen. This is the volume, this is the air, but when you're giving without the intercooler, it's much more better than the direct injection system or the naturally aspirated. Here with the intercooler, it is much more cooled so that it gives you much more better performance. So performance is always power, torque, and the fuel efficiency. End of the day, we speak about the emissions also. So these are the parameters what is very important. So let me study about the turbocharger. So how is the turbocharger? So due to compression by turbocharger, the temperature of the air increases. So the temperature of the air also increases as it comes in contact with the hot turbocharger. Okay. The intercooler is fitted after turbocharger to cool the air and make it much more denser in the oxygen levels. This is already spoken. So let me go ahead with the next. The intake of the atmospheric air which is sent through the air filter. So after getting it clean, it gets to the turbocharger and gets compressed through the intercooler. So this cools the hot air and sent to the engine through the throttle body and to the cylinders. And how a turbocharger runs is here. Because of that burning the fuel, that exhaust gases, right? So those exhaust gases being sent out. What happens here is there's a turbine here, there's one shaft, and there's a compressor. So when this turbine runs, this compressor also runs. So this exhaust air will spin this turbine and goes out. So here, when the turbine runs, the shaft is there, right? So the other side we have the compressor. When the compressor runs, that takes out the fresh air and compresses it to the engine through the intercooler, making it much more cooler. So emissions are lesser, performances are much more better. So there is torque, power is increased, and as well the fuel efficiency also is much more increased. We have seen about the turbocharger. So now let me go ahead and see what is supercharger. So supercharger is this here. Turbocharger and supercharger works in the same way, but turbocharger is in the centrifugal type, but the supercharger, it has a screw type inside, so that it takes the fresh air and compresses it to the engine, but it is fixed just straight above the engine itself, and there's a pulley, there's a belt also. So actually a turbocharger, it is being run by the exhaust gases to run the turbocharger. So how much the exhaust gas spins and goes up, so much the inlet gas is also being taken. So that's how this works. But a supercharger will work as per the engine's revolutions per minute, that is engine's RPM of the crankshaft. So this is belted to the crankshaft, right? So how fast the engine runs, so much the supercharger also will run. But these are not much fuel efficient as the turbocharger. This can give you better performance, even including fuel efficiency, but it is not as turbocharger. Turbochargers are much more better in getting you the very good power, torque, and the fuel efficiency, and much more better emissions. There are some power losses in this because the engine's power has been taken to the supercharger. Whereas a turbocharger, the exhaust gas are just going out, right? So it's something like we have told the exhaust gases to just spin the turbine and then get out, so that the turbocharger runs. So it is very simple. Turbocharger works through the exhaust gases. Supercharger works through the crankshaft. Simple. So this is how it is. This is the air filter. Actually, these are fitted on top of this, and I just for better understanding I made it like this. So this takes the fresh air, compresses it to the engine directly. The exhaust goes out, and there is no exhaust connected to the inlet or the supercharger.